Good morning. Let's get straight to markets.
Take a look at the impact for the indices.
Factual. Succinct. All you need to know before your trading day starts. Subscribe to our newsletter, CNBC's Daily Open.
Welcome to Beyond the Valley, a CNBC tech podcast with Arjun Karpal and Tom Chitty.
Beyond the Valley.
How hard is it to make a microchip? Very, as many countries are finding out. Semiconductors, as they're often referred to, are everywhere, and as you'd expect, a race to develop them is intensifying. This week, we'll find out what goes into making a microchip, good luck Arjun, who the runners and riders in chip design and manufacturing are, and where one of the greatest scientific feats will go next.
Beyond the Valley.
Best of luck with explaining microchips.
Thanks, Tom. Do you know what gave me this idea to perhaps do an episode on this? Apart from the fact that it's super important and, you know, it's all over the news and
Everywhere.
it will help
in our lives. Yeah.
Everywhere. I came across my old PlayStation 2 the other day.
Right.
And I thought, this is cool. I bet it's got chips in it. Maybe we should do an episode on chips.
That's how your brain works?
That's how it works. But also, I was like, do you like retro tech? Do you have any retro tech laying around?
I'm not. No, I tend to get rid if I don't use.
I think
which
I've
is
got
pretty bad,
all my consoles.
Really?
That I've ever owned. I think so. Well, I hope my parents have kept in.
I imagine some of them must be quite valuable now.
I don't know. Do they need to turn on?
Do they need to work to be valuable?
I like coming across a piece of sort of old school technology.
What would be your oldest console?
The first ever PlayStation, probably. Yeah.
Is that older than the N64?
Well, actually, my oldest console, I mean, my dad, I hope, or maybe a Game Boy, actually. A Nintendo Game Boy, potentially.
Yeah.
Yeah. I'd love to see a Discman.
A Discman?
Yeah. Is that what they're called? Yeah, they were.
Yeah, Discman. What was the one with the... Was it Discman?
Discman? Walkman?
One with the, they were kind of mini cassette.
Oh, yeah.
What were they?
I can't remember now. But those are cool. Those are very cool.
It's good we know it. We don't. Really informative tech
very
podcast.
Informative.
What were they called?
Yeah. You know who can help? Our listeners.
That's true. Thank you. Great segue. Yeah, you can. If you'd like to tell us your oldest bit of tech or oldest console that you've got lying around, then you can email us at beyondthevalley@cnbc.com. And if you'd like to keep up to date on the world of tech, then the best place to start is the Beyond the Valley weekly newsletter, packed with the best international tech stories from CNBC. You can subscribe by heading to cnbc.com/Beyond the Valley. Click on the subscribe button and a newsletter will drop in your inbox every Friday. Before we get to our main story, we've got to hear Arjun's stat of the week, which is...
75% market share, Tom.
Back to the market share.
Yeah.
All right. So back to our main story. Arjun, as we always like to do on these podcasts, let's take a step back and look at the process or what goes into making semiconductors.
Well, it's incredibly complex, Tom. That's for sure. I was doing some reading and I thought I'd start off with some very the fun facts. This could have been stat of the week, actually. But some fun facts here. So the semiconductor manufacturing and production process from start to finish is incredibly complex. It's intricate. And it takes... And this is a McKinsey report I was reading. It takes around 4 to 6 months and involves more than 500 discrete stages, ranging from specialized design software all the way to the fabrication or manufacturing plants and dedicated test facilities. Another fun stat from Accenture here, a consulting firm, they say the various inputs to a typical integrated circuit chip, these are the ones we're often talking about, must cross more than 70 international borders before a final product can be delivered to consumers. So that gives you a sense, I think, of that. And if we look at the process, I'll give you high level here and we'll dig into it. The process can be broken down into these stages, I'd say. Firstly, it's the design of chips, which involves things like design software and design architectures. Again, we're going to dig into this. The second part is the actual sort of fabrication or manufacturing of these chips, which involves the equipment manufacturing companies, the raw materials that actually need to go in to making some of these chips as well. And the final one is the sort of assembly, testing, and packaging of these chips. And then, of course, delivery. So that's broadly how you'd sort of break down the process.
Over the years, the semiconductors, the aim really in terms of that design element and manufacturing has been trying to make them as small as possible. How big were microchips back then? Intel, right, were leaders, but they were much bigger than...
They were a lot bigger, yeah.
Like the size of our hand, maybe?
Yeah, somewhere like that.
Yeah, somewhere like that.
Quite large, weren't they? Yeah. They were quite... I mean, you see sort of some of the chips now and the circuits involved, they're tiny, and the amount of power they can generate in terms of computing power, that is, and in terms of they're using less power consumption, which is the aim really. It's to increase the amount of computing processing power available from that chip, but also reducing the amount of power they're consuming on our devices, right? Because you don't want a phone that's doing all this sort of really high power computing, but actually the battery's dead in 2 hours. Yeah. So that's some of the big advances that have been made, I think, over the years.
Just for our listeners, if you want to sort of gauge kind of the size or how small leading cutting edge semiconductors are these days, they are smaller than a 1 micrometer bacteria, or you imagine something like a virus, which the mind boggles as to how you could even start working on a physical thing that is that small. But anyway,
so small, tiny.
Just to get your heads around that. So we talked a little bit about the various processes involved in making semiconductors, but talk to us a little bit about the scale, the global scale of the microchip supply chain.
Yeah, so I mentioned it's complex, it's intricate, and I broke down into those parts. So let's dig into those each further. So the design, did you know originally, this is what I read anyway, chip designs were hand-drawn?
Really?
On individual sheets of paper. I mean, if they were less complex, maybe you could, they had a few transistors on them, that's it, not too much going on. You probably could hand draw them. Definitely couldn't do that now. Absolutely not. But now all of those designs, so this is a design process. It's all electronic, and they use these electronic design software and tools to do so. Now, in the area of design of chips, it's the US and Japan that dominate. Companies from those countries that dominate this area. And then the other part of design is, if you're a company and you want to build a new processor, often you're not designing it all from scratch. You're basing it on an existing blueprint or architecture. And those are from companies like ARM, which we've spoken about in a previous episode as well. So as part of the design, yes, you've got your design software firms, and then you've got your kind of core intellectual property or blueprint firms. And here, the US, again, very strong, and the UK, thanks to ARM.
So in that design process, there's two facets to that. So you could be very good at design, but also you could create blueprints. Is that what you're saying?
So with the blueprint side of it, very few companies are in this area. And we'll talk about this, but very few companies are in that core IP. It's ARM and a handful of other companies that have that core intellectual properties around design. And so often, if you're a PC maker, you may base your design on ARM architecture. Often that is the chip for the chip. Or if you're a PC chip maker, or if you're making a processor for a phone, again, this may be based on an existing design, and you can customize that to some extent. That's really a lot of the way.
But the innovators when it comes to design are only a handful of companies, one being ARM. Yeah,
one being ARM in terms of the core IP, but you see some company like an Apple, which bases some of its chips on ARM designs, has also innovated, but by customizing some of these core blueprints in order to specify it to their devices. So the chip I think it's important to think of the chip as one component in a larger grand scheme of things. It's incredibly important, but you could have the best chip in the world, but if you don't integrate it into whatever devices, it's not going to make a difference, because you've not managed to successfully connect the chip to everything else going on in, say, a smartphone. That means the camera, that means the screen, that means the battery, that means everything else.
So that's the element of design you're talking about, is actually the integration design from taking a chip and then building it within your system.
It's all of that. So it's the design of the chip, but then, it has to go further. If you're a device maker, you then have to figure figure out a way that chip is then, you've designed it, one of the most powerful chips around, you've designed it, and it's AI capable, it's everything, and you don't know how to integrate that chip into your smartphone. That is something that
chip is fairly useless.
Yeah, and I think you actually see it. A good example is this: Apple designs its own chips for its iPhones. They are the most cutting edge smartphone chips around. They are sort of at 3 nanometer for the latest iPhone range at the moment, and they use it across their iPhones. Now you look at a company like Samsung. Samsung has designed its own chips for its phones called Exynos, but it doesn't use them globally. It still relies heavily on Qualcomm chips and uses Exynos in some markets, which tells me that perhaps Samsung hasn't quite figured out the chip side of the equation. So again, yeah, they can design cutting-edge chips. Samsung is one of the leading manufacturers of chips in the world. So it can design, it can manufacture its own chips and then put them in the smartphones. But it still hasn't figured out a way that it's confident enough to roll these out globally. It still relies heavily on its partners like Qualcomm. So you can design it. If you can't integrate it as well, doesn't make a difference. So that's part. So key is design here and then integrating it into the device. And then as part of this process as well, you've got the raw materials side of the equation. You need materials to make this. Things like gallium, like tungsten, some of these metals. China here is extremely strong in this area, South Korea and Taiwan. So in the materials segment, you're seeing sort of Asia be quite dominant. Then you've got the actual manufacturing side of things. And as part of that, you've got the actual equipment required to manufacture, which comes in 3 stages. What they call the wafer fabrication equipment, packaging, and then the testing. So the US and Japan basically dominate all these kind of areas. So with wafer fabrication equipment, US and Japan is key. But also, while they are key, the most important company in this is a European firm who we've spoken about before called ASML, a Dutch company. They make these so-called extreme ultraviolet lithography machines or EUV machines, and they are required to print effectively the most intricate layers of a chip, right, on these silicon wafers, and the EUV machines are required to make the most advanced chips in the world. Then you got the testing, US and Japan very much dominating their companies, and in packaging up all of it, Japan is a strong player here. And then finally, you've got those equipment makers. Finally, the actual manufacturers who buy that equipment and manufacture those chips, TSMC, Samsung, they are the 2 dominant players, accounting for around two-thirds of the foundry, so-called foundry market. They're called foundries, by the way, these fabrication companies.
And is anyone else other than TSMC manufacturing chips?
Samsung, Intel,
yep,
UMC. So there's a handful of other companies.
And some companies in
SMIC
China.
SMIC in China, which is China's largest foundry there. So those are sort of but when you look at the concentration of the market here, 2/3 of the market, of the foundry market by revenue, is Samsung and TSMC.
Do we expect that concentration to continue, for it to remain in the hands of so few?
Yes. It's incredibly difficult to manufacture a chip, which I hope we all can hear from what I've laid out so far. It's not easy. You can't just set up a foundry overnight. It costs billions of dollars to do so. And forget the money. The expertise required is also...
you need highly skilled workers.
Highly skilled workers to do so. And so that concentration is not going to change at all. Now, the hope is that perhaps there are new players or existing players like Intel who could catch up and pick up some of this slack. But right now, I don't foresee the dominance of, in particular, Taiwan Semiconductor Manufacturing Co., TSMC, being dislodged anytime soon.
But Intel used to be a leading player when it came to the manufacturing of chips. What happened?
Well, we have to sort of go back, I think, a little bit. A couple decades ago, the sort of accepted wisdom then was you sort of integrate everything. You design your chip, you manufacture it, great. Then chips got more advanced, more complicated. You needed very specialist tools, machinery, etc. It's very expensive to do. And then this so-called fabless model emerged, fabless. So this is where chips are designed by one firm and then sent somewhere else. If I was a company, I designed my own chip, I needed it manufacturing, I'd ask TSMC, I'd put in the order with TSMC and say, can you manufacture this chip for me? I need this many. That's it. And in this, Asia emerged as the key player, and in particular, as I mentioned, TSMC and Samsung in South Korea. And Intel, which was once one of the leaders, just lost its way.
Ambition to me is about doing better.
I think ambition creates a pathway.
The best advice I can give to someone starting off a career is don't have a career, have lots of careers, try loads of different things.
Talk to people and put your ambition out there.
I don't feel that I've hit peak ambition because it's a learning journey.
CNBC is where ambition meets opportunity. What does living ambitiously mean to you? Hear it from our CNBC anchors, reporters, and global business leaders on CNBC.com.
You're saying that the concentration of power when it comes to semiconductors isn't about to change anytime soon. Then why are countries working so hard to try and get a piece of the pie if you don't see the sort of power balance shifting?
Yeah, so the concentration of suppliers in the market is a really important point for this discussion about the geopolitics of chips, right? Just to give you an example, silicon wafers, imagine them, they're huge sheets of silicon which the chips are basically etched on and cut out of, and you end up with a chip. About 5 companies supply these silicon wafers. Well, there's more, but 5 companies account for 65% of the market. In the extreme ultraviolet lithography machines, 1 company, ASML. For the core intellectual property, I was talking about companies like ARM and others, very few companies as well. Again, in design, very, very few companies, a huge part of the market. That means that if you look at the sort of world in terms of who are the biggest countries for various chip firms, the US emerges, Taiwan emerges, Japan emerges, South Korea emerges. These are the big players right now. And what does this mean then? And why are companies all of a sudden talking about making chips and everything? I think COVID was a huge part of the equation. What happened with the pandemic was, and we heard a lot about this, chip shortage, right? We kept hearing chip shortage. Car makers couldn't get the chips required for their cars. Device makers, gadgets were in short supply because they couldn't get the chips for those gadgets. And so this underscored, I think, very quickly how critical semiconductors are to our everyday life. And governments started to take notice about this. They started to see, yes, they're important for consumer electronics and the economy, but they're important for the military. They're important. Now this became a national security issue. And that's where I think there was a huge sort of mindset shift, at least publicly, to acknowledge these are critical components, and securing the supply of them, making sure there's no shortage of semiconductors is now a national security issue. It's for the government to step in and do something about. And now all countries want a piece of the action. And what you see now, particularly led by the US, is the country trying to reshore the manufacturing of chips back to the US, which was once a big leader in the space. With Intel. Yeah, and now the US wants to know that actually, if there's any kind of global conflict, if there's any kind of pandemic, if the US on its own shores will be able to access semiconductors.
And even from a civilian perspective, if your society is not able to properly function and businesses aren't able to operate, then that's a security risk. And can destabilize an economy. So when we talk about the semiconductor, there's ramifications to all of this. We talk about the US trying to sort of claw back some of that market share. How's it going to go about doing that?
So we've seen a few moves from the Biden administration, 2022. They signed the CHIPS and Science Act, effectively unlocked sort of over $52 billion of funding for the semiconductor industry. And around 39 billion of that was specifically toward manufacturing. And what the US has done with that money since is try to lure TSMC, Samsung, and, others onto their shores to set up shop there. And in particular, the big focus on manufacturing those chips. And so far, they've been pretty successful. I think all TSMC and Samsung have both committed to opening new plants. They've been given billions of dollars to do so. Intel also has been given billions of dollars as well to be able to sort of continue to expand its manufacturing operations. And so that's what's been happening so far from the US.
That also, there's a reason why they probably want to accelerate that move, particularly for TSMC, into the US because of the threat that potentially a future conflict between China and Taiwan may be in the offing?
Yes and no. I mean, this is it's beyond my wheelhouse. There's been plenty of theories about, China's intentions for Taiwan and how it sees it, and whether it's to do with chips or not, or what the conflict could do. Well, TSMC, I think, has come out and said, look, if there were any invasion of Taiwan from China, we literally wouldn't be able to operate. Like we would have to shut down everything. And I think importantly, this is not a move out of Taiwan. This is a brand new facility which will expand production. And it's unclear at this point what kind of capabilities this new facilities will have. Will they be doing leading edge chips, or will that still be in Taiwan where all the expertise is? So I don't know if this is necessarily... Partly, yes, there's certainly going to be those tensions or underlying thoughts of what happens if disruptions to TSMC's operations in Taiwan happen. But importantly, this is not, I think, a move out of Taiwan. This is an expansion on existing capacity. So whatever they got in Taiwan, they're expanding on that capacity here in the US. And these chips are going to be for the US, but they're also likely going to be exported globally as well.
But also they are shoring up their supply of semiconductors. They're neutralizing in a way some of that threat, that if something were to happen, that they still have the machines and the manufacturing know-how on American soil to be able to continue producing semiconductors.
Absolutely, yeah. It's a big part of the consideration, yeah.
Within that supply chain, there are going to be ways that various companies can be affected or disrupt one another in terms of making the semiconductors. So it's not a closed shop, if you will. There's still going to be that exchange of intellectual know-how, manufacturing expertise, materials, whatnot, between foreign firms. So it's not like America can just go, right, from start to finish, we are going to be able to make semiconductors.
And that's the crux of all of this, Tom. The crux of this whole episode. No one country can own the semiconductor supply chain. It's impossible. It's genuinely impossible. There are too many companies involved. There are too many points of where any one country could be cut off in some way from this supply chain, that America's efforts now in terms of reshoring that manufacturing are just one point of the equation. But what if, there were a situation where China cut US off from some of the key materials, raw materials required for the production of semiconductors? There will always be a weak spot somewhere. And I think what the US is trying to do is to its best efforts, mitigate any disruption from that. But that is really the crux of it. Why no one country can own the semiconductor supply chain and semiconductors more broadly is precisely because of that. The global nature, as sort of laid out at the start with the intricacies of the supply chain, the various parts, the various countries involved, that is very difficult. And I think that's where the US strategy has been twofold or threefold. One, do something like the Chips and Science Act, unlock funding and money to incentivize companies like TSMC and Samsung to set up shop. Two, draw the semiconductor industry along geopolitical lines. The US government and government officials, including President Biden, has been meeting with heads of states from Japan, from South Korea, from nations he sees as allied both politically, but also from a technological point of view. It's no surprise that a Taiwanese and a South Korean firm have set up shop in the US, right? So this is what the strategy is. That's the second prong of it. And the third prong is to cut off China from technology.
I suppose that leads me to my next question. Where does this leave China when America are making these significant moves?
In a difficult spot. China has been hit with a number of export restrictions that have effectively cut them off. And this is a great example. I think this is the example to lay out and I think, really kind of bring together everything we're talking about, right? China has bits of the supply chain, right? It's got a manufacturer in SMIC. It's got a couple design firms, et cetera, et cetera. It's got companies, internet companies, that want to design their own chips, like Tencent or Baidu or Alibaba. We've seen that in America with companies like Microsoft and Amazon and Google designing their own chips. That's something that's happening more and more. Now, the problem for China is it's been hit with so many export restrictions that parts of these supply chains are cut off from it. So I mentioned ASML earlier in the show. They make this EUV machine, the only company in the world to do so. And this EUV machine is seen as a key tool in being able to basically manufacture the most advanced chips on this planet. China has never been able to receive one of these EUV machines. The Dutch government, under pressure from the US, has effectively blocked ASML from shipping one of these out. This has seriously hampered SMIC's ability to manufacture the most advanced chips at scale and efficiently. So that gives you a sense. Now, you've also got a lot of the chip firms out there, the internet firms wanting to design their own chips. They will rely on American design tools. If those design tools are next under any kind of export restrictions, then again, that's going to cause some problems in chip development. So China's a good case study of what happens when, you don't necessarily have a homegrown semiconductor industry, and also, the countries that do have a lot of those key things, the tools, the design tools, the manufacturing, are aligned with each other and against you. And that's kind of what sort of happens. So it's a tough spot for China, and they're finding out very quickly how global in nature this supply chain is, how they don't have a lot of the homegrown technology to do it, and how that's going to take a long time to develop. And so this is a great example to basically bring this story together, that no one country can own the semiconductor supply chain, how complicated it is, how intricate it is, and why I think it's been brought into the geopolitical sphere. And that's how it's going to play out going forward.
I think if our listeners didn't know anything about semiconductors, that's given them the comprehensive overview of the state of play when it comes to microchips. So well done. Smashed it.
I think it was pretty good.
Yeah.
I hope so. Well, our listeners can let us know.
Yeah, exactly.
Which we like. We like their opinions.
Exactly. What did we miss?
What did we miss?
Probably a lot.
Well, there's so much.
There is so much. Exactly. You can't get into everything. All right. Start of the week then.
75% market share.
The thing is, again, like last week, you mentioned
I did.
Did you mention it again this week? Because you mentioned 65% market share at one point.
Yeah.
So it's not that.
It's not that. Okay. That's a different number.
So 75% market share. The market share of TSMC chip manufacturing?
Close. You're close, Tom. It's the market share combined of TSMC and Samsung in semiconductor manufacturing, in the foundry business. I did mention it, but I used the phrase 2/3.
Well played. You're now sort of throwing me off the scent.
Yeah. I realised my mistakes from last time, and so I sort of tried to phrase the figure in a. I know it's not exactly. I said sort of roughly 2/3. So
breaks a nice run. I was on a good run.
You're on a good run. It was good. I mean, you got close this time.
It was pretty close.
Yeah, it's pretty. I'm not going to give it to you though, sadly.
So I just also wanted to mention that we are plans to head to VivaTech in June. Is it June? May. Sorry. So
I think May. Yeah.
So next month.
Yeah.
So if any of our listeners are going to be there, we're going to be recording a live episode at VivaTech.
How exciting.
So exciting. And if you'd like to be part of the audience, then you may have to email in and we can divulge timings and where you need to be to be able to get front row seats.
We might even bring some of the swag with us.
Yeah.
The merch. It's all very exciting.
Very exciting. Very exciting.
But we're going to take a little break after this, aren't we? We're going to take a week off?
A week off, and we'll tell our listeners next why in the next episode.
Yeah.
But for now, thank you, Arjun.
Thank you, Tom.
We'll be back in 2 weeks for another episode of Beyond the Valley. Goodbye.
Beyond the Valley.